to The Routing Loop, our weekly show about anything to do with AWS networking. I'm your host, Tom Adamski. Worked for AWS, been in AWS for 7 years. You've probably seen me on the previous shows. Today I have very interesting guests. I brought up partners from Tailscale. Let them introduce themselves, but we have an interesting discussion on what is Tailscale doing and VPNs and zero trust access. Let me let you guys introduce yourself. So maybe Alan, you wanna say
Sure.
a few words about what you do, who you are, where you're based.
Yeah, thank you, Tom. Hey, well, hello, everyone. Alan Valancourt. I'm one of the solutions engineers over here at Tailscale. Been here for about 1.5 years. Before that, I spent a good bulk of my career in the production trenches, Linux admin, developer, network admin, and setting up remote stuff, previously the old hard way. So based here in South Carolina, where it's supposed to be cool this time of the year, but it's not right now. So if you're in an area where it's cold, please send us some cooler weather because I'd appreciate it.
That is only something someone would say that has warmth.
That's right.
If you had a proper winter, you'd never be asking for the cold weather.
True. That's very true.
You could counter
Alex?
that with, if you had a proper summer, you'd never be asking for heat ever again, though, because after 6 months of a Southern American summer, you're pretty much done with it. So I can speak to that. I live in Raleigh, North Carolina these days. Clearly, I'm not from here originally. I'm originally from England, from London. And I've been at Tailscale now for 1 year plus, 1.5 years. Before that, I was at Red Hat doing a bunch of OpenShift stuff as a TAM for a while. But here at Tailscale, I'm head of developer relations, and I look after the YouTube channel, put a bunch of stuff out in my spare time as well, the self-hosted podcast. I co-host that with my good friend Chris Fisher over at Jupiter Broadcasting. And yeah, big open source, big self-hosting advocate here because of the home lab crowd particularly. And obviously today we're speaking AWS, I know that, but historically home lab's been where my heart's at.
Yeah, we can mix it up. People are interested in ways of connecting AWS to on-premise to AWS, themselves to on-premise. So we can totally mix it up. So do you guys are going to have a few demos for us and show us how the service works, what it does, take us through the basics. Is that right?
Yeah. If you want to bring my screen up, I've got some stuff up here on the screen right now.
All right.
So we like to talk about Tailscale as the easiest way to connect your devices and services together. So what I'm showing you here is the hub and spoke network of VPNs, for which we've all been using for the last 20 plus years. You have a client and you want to connect to a resource somewhere privately. So you put a VPN gateway between you and it, and then that becomes the gatekeeper, the Gandalf on the bridge saying, you shall not pass, right? However, with Tailscale, we kind of changed the game a little bit with this by doing what's called a mesh network, which means every node connects to every other node. But in particular with Tailscale, the thing that makes this work so well, you'll probably notice there's no hub here for these things to talk to each other, is something called NAT traversal. So what is NAT traversal? It's a way to punch through firewalls without having to touch or configure them. So if you've ever had a 192.168 local address, rather than your ISP's WAN address, you are using NAT whether you know it or not. And your local laptop likely doesn't have a public IP address. So if you were to try and connect to it over the internet, you would be hitting your firewall first, which would probably drop the packets because most firewalls are set to default deny on almost everything. So in order to work around that, you'd have to do typically something called port forwarding, which would create a static rule in the firewall to say, send these packets to this destination. And only if it matches these specific characteristics shall you allow this traffic to pass. Now, obviously, there's plenty of situations where you don't have control over a firewall. I was just telling you in the pre-stream that I was on a plane the other day and I wanted to SSH to my server in my basement. And I didn't have access to the firewall particularly easily anyway. And I was able to, using Tailscale, make a direct connection from my laptop on the plane to a server running here in Raleigh in my basement behind a firewall with no ports open. And really, that's the crux of it. That is what Tailscale does in a nutshell. There's a bunch of other magic that we can get into today, talking about the coordination server and how the key exchange happens and that kind of thing. But that's the kind of crux of Tailscale in a nutshell.
So maybe we can start with talking about some of the use cases, but I'd really love to dive deeper into kind of exactly how you guys do it. So where do you typically see use cases for Tailscale? Is it like a replacement for a site-to-site VPN connection between two environments? Is it more of a like adding encryption in places where encryption doesn't necessarily exist between endpoints? Is the bandwidth the driver? What would be like a typical customer for you that would go, okay, Tailscale solving a big problem for me?
Yes, and it does all of those things and a great deal more. One of the most common things we see, particularly as it relates to Amazon at least, is we have this thing called a subnet router, which essentially acts very much like the hub and spoke, the Bastion server that you've been used to in your remote environments. And people will install Tailscale on that node and then turn on the subnet routing functionality and route packets through those nodes. So instead of creating resources individually in a VPC that have Tailscale enabled, RDS, for example, would be a really good example. They can route the traffic through the Bastion node and have it come out as if it was routing from the Bastion node and hit, the RDS front end or whatever it turns out to be, as if the traffic originates on that box itself. We do offer a feature as well, which this is getting a little more esoteric, but you can turn off SNAT. So if you want the original origin IP of those packets to be preserved, you can turn off SNAT, and there's a bunch of cool stuff there. I'm sure Alan's got some pretty interesting use cases though as an SE.
Yeah, for sure. I see a lot of customers that might be running an old legacy system, connectivity tool or VPN that just was great when everybody was in an office. And then when COVID hit and the working from home became the norm, this technology stuff didn't scale well, because now I said, hey, I don't have to live in this state. I'm going to go move 5 states away. But when you look at a traditional connectivity tool, VPN or something, well, maybe they're in Ohio, they have to connect to their concentrator in California to get back to the AWS data center. It's in Ohio. And there's a lot of performance issues. So we come along with that, said Tailscale can make this better. Now they can, as Alex mentioned, directly connect to those resources in AWS from Ohio and wherever they're at seamlessly with, higher performance. And then when they're done at home, they go to a co-work place or a coffee shop and easily. And so from developer engineers, security teams, it's a huge win in their books, knowing that, hey, this is all encrypted. This is tied into their identity that we control. And so we can be really granular, kind of building those frameworks of zero trust and access for them across the way.
Yeah, I remember those times where, COVID hit, everybody went on Zoom, and then all of a sudden you're like, why is my Zoom operating so terribly? And it turned out you're going through a VPN somewhere and then breaking off ways away from where you are. But I guess, so what would be the applications that you normally see for your use cases, right? Because if you're saying, okay, I don't need to go to a hub, instead, I'm going to have a peer-to-peer connection, ultimately, quote unquote peer-to-peer, but directly VPNing between two endpoints. What's the applications that you're seeing that are benefiting from this the most?
We're going to touch on this a little bit today, but one of the really big ones is treating multiple cloud providers as if it's one big flat network, and you care very little beyond the performance characteristics of each cloud provider and what they can actually offer you. You care very little about where things are actually hosted. So there might be a situation, for example, where you have to comply with a HIPAA regulation or some other compliance thing that means you have to host a bunch of data on premise. However, you want to put the front end of your application closer to your users. So put it in a what do you call it, CDN or something like that. Wouldn't it be great if you could connect those two things together without having to use something like a direct connect? And one week you're going to put it on Amazon, the next week you're going to put it on Azure, whatever's closest geographically to your users, that kind of thing. Well, with Tailscale, you can do exactly that. And not only that, but for example, say you've got a CI server that wants to connect to a random database on a developer's laptop. Trust me, it happens. I have a GitHub action, for example, that deploys a website that where every time it runs, it creates an ephemeral connection from the GitHub Action Runner kind of workspace into a droplet running on DigitalOcean, does what it needs to do over Tailscale using Tailscale's authentication with Tailscale SSH, which again we'll get into in a minute. No SSH keys or anything like that are required. And then it just destroys and just goes away and stops existing. And when you can start to treat infrastructure as disposable and programmable like that, it really opens up a huge world of possibilities. I remember there was a time, this was probably going back about 10 years when I was doing my comp sci degree, but we were emailing. This is so embarrassing. We were emailing source code around to each other in zip files on, I can hardly say this, Facebook Messenger. Because Git was too complicated, apparently, for our professors at the time. And Lord knows that the people on my team weren't going to learn it either. Whatever. So what Tailscale would have allowed us to do would have been, I could have hosted, this is, talking 10 years ago, I know, but I could have used a tool like Tailscale back then, big time. I was hosting the local development database on my laptop in my house, and it would have been great if the girl working on the front end on my team had access to that database, and so we were constantly in sync whenever I made changes to the code. So there's a bunch of things you can do with Tailscale like that just improve developer velocity without increasing, in fact, greatly reducing the friction and complexity that they have to deal with. We all know that network teams are severely underworked and never have a backlog of tickets. They're literally sat around playing ping pong, waiting for work to come their way, aren't they? That's always the meme, right?
Yep. Okay, so I wonder if we want to have a kind of look, because we talked a little bit about use cases, but I'm curious if we could just have a see of how
Absolutely
how you actually deploy it. How does it work?
All right.
So we can see a live walkthrough.
Okay, so you can all see my terminal, hopefully. I know it's a little small on the stream, but it's about as big as I can make it, I think. So I've got two windows here. On the left, I've got an AWS EC2 instance, and on the right, I've got an Azure Linux VM. The Azure VM was created using Terraform, and this is already logged into my tailnet. As you can see, I do a Tailscale status, and this node is on my tailnet. Now, those of you that are paying attention will also notice there's an item in this list called Baldric, which is this laptop I'm speaking to you from right now. Think about the network topology between this Azure VM and my laptop on the desk in front of me. I can do a Tailscale ping Baldric, and watch what happens. A direct connection from Azure Cloud through all of the different network topologies in the way directly to this laptop on my desk with no configuration. And I'm going to prove to you that there is no extra configuration because this EC2 instance here doesn't even have Tailscale installed. So we're going to go through the process of setting Tailscale up live on the stream. Please be kind to me, demo gods.
Here we go.
Here we go. All right. So I'm going to download Tailscale first of all. You can go to our website to download it for free. You can get started for free with 100 devices and 3 users on our free plan. If you need more than that, you can reach out to myself or Alan, and we will happily sell you some stuff. This is the command to install it, though. It's just a very simple curl command, which brings down a shell script. So I'm going to put this into my EC2 instance here. And it's going to go out and this is an Ubuntu machine. So it's going to create the apt repos in the sources list file and do everything it needs to do. When it's finished, we're going to have Tailscale installed on this machine. Now, what I need to do is actually log into Tailscale on this system next. So I do a Tailscale up. I'm going to do a --SSH. Okay. I also want to prove to you, by the way, that there are no SSH keys on this device. In fact, I'm going to remove that right now. So there is nothing here. Okay, it's a brand new machine, literally created 10 minutes before the stream. There's nothing in the SSH directory. There's no authorized key file, nothing. Okay. In fact, I realize that's dangerous for me to delete that file because I'm connected via SSH right now. But oh well, what could go wrong? Tailscale's installed. Okay, good. So I will go back to being root with sudo and do Tailscale up --SSH. And what this will do is it will now authenticate me to my tailnet. So I do a command click on this in the terminal. It's going to bring me to the Tailscale admin console. What I need to do here is authorize with my identity provider. And you'll notice there are a bunch of different providers here: Google, Microsoft, GitHub, Apple. We support custom OIDC providers as well as a lot of the big ones. Tailscale doesn't want your password. We get this question a lot of why don't you just give me a username and password? Well, it's because we don't want that for GDPR reasons, for a whole bunch of other data protection reasons. We'll let the OIDC providers like Google and Microsoft and GitHub handle all of that stuff. All right, so you can see that in the background here, this is now connected to my tailnet. So if I do, again, a Tailscale status, bada bing, bada boom. So what we're going to do is from this AWS host here, in fact, no, let's do it this way around. From the Azure host, we're going to do a SSH Ubuntu at, what did I call it? AWS US East stream test. There you go. You see, it's already picked up the fact that it's got a Tailscale IP address, 100 dot something. Permission denied. That must be in my ACLs somewhere. So again, we're just proving that the product works here, I think. I think it's because the Azure VM, if I bring over this page here, it's because this node is tagged, whereas this one isn't. So it's kind of owned by a different person. So I should probably talk about that a little bit. Don't worry, the failure was entirely deliberate. It's all part of the master plan. Trust me.
So Alex, maybe do you want to talk about the constructs? So there's a piece of software that you have to install on the client and the server. Do you differentiate between client/server, or could everything be at the same time a client and a server?
Great question. So everything is a client, and everything is also a server. Remember how I said it was a mesh network and everything connects to everything? So what happens in the background is each of these nodes is running the Tailscale server, listening for incoming connections. It's also a client sending out those connections at the same time too. Those connections happen over WireGuard. And in order for these clients to be able to find each other, we use a central coordination server, which is hosted by Tailscale. This doesn't really do a whole bunch other than store some very basic information about the origin of NAT packets in order for us to allow those two devices to find each other on the internet and punch those holes in the NAT to make those direct connections. It also handles the key exchange under the hood too. And I know Alan has a really good way of explaining the key exchange, so I'm going to toss that to him.
Because we use WireGuard as the underlying protocol there, and the private keys stay within those devices themselves. So when a device is connecting to another device, they exchange their public keys, say, hey, I'm here, I'm Alan, I need to connect to this device. The other coordination verifies it, and then, hey, those match, so we're going to let that connectivity go through. And the nice thing is they're all there in your telnet, fully secured, and no way to get access to them. For like the SSH piece here that Alex is going to show, it actually generates temporary encryption keys for these SSH sessions. And then once that is over, it will expire them. So when you look at us former network admins back in the day, I remember my last production, we had 80, 90 servers and 20 developers and public keys for everybody. And you multiply that, and that's a lot of public keys sitting running. And I was using Terraform or manual to update. And then sometimes somebody will leave, you didn't get notified. Guess what? The public key is still running on a server somewhere, right? You didn't clean it up properly. So by leveraging some of this aspect of it, tying it to identity simplifies, from those on the DevSecOps security teams, they're like, oh, I can reduce some of my PKI headaches and managing a lot of the static credentials by, leveraging WireGuard and what it's good at.
So when the client is installed, client/server, it auto-generates a pair of keys, public and private. It will keep the private key stored locally, and then it shares the public key. I'm assuming when you're connecting to the Tailscale up, when you set up Tailscale, it connects to the login page that's when it also shares the public key, and that's how you trust the public key, because someone has the right credentials and identified through the IDP. Hey, I'm really who I say I am, so you should trust this public key that I'm now providing to you. Is that kind of how it works? Because I'm curious how the public key gets validated, right? Because you have with PKI, we have all the CAs, and that's the verification process, the whole public key infrastructure. Here, I'm assuming the public key is trusted because it's been shared during the login process. Is that, am I right? Am I on the right track?
Almost. So what's happening on the remote host is OpenSSH is running, let's assume it's running as a standard SSH server on port 22, right? We're all familiar with that, public key infrastructure, blah, blah, blah. What Tailscale does is it runs its own version of an SSH server in Go. And so what it's doing is it's listening for incoming connections on the Tailscale interface, the 100.ip block. And so when an incoming connection comes in over the tailnet, it's able to validate your identity against the Tailscale network and say, oh, this is coming from this source, this node is owned by this person, or this tag, you are or are not allowed. And as we saw, this is exactly what happens here when you're not when you haven't configured your ACLs, well, I say correctly, when you haven't configured your ACLs to allow that user access to that remote host. This is exactly what happens. It says permission denied. So it's running a proxy SSH server inside Tailscale alongside the OpenSSH server. So you can still connect with your legacy tooling as well as using the Tailscale SSH tooling that's built into Tailscale.
Yeah, unless you deleted your SSH keys. Then your legacy might not work.
Yeah, I was a bit trigger happy with that, wasn't I? But such is life sometimes. So does that make sense with the SSH keys and the kind of proxy server and all that that's going on?
I think so. If folks have questions on the chat, pop in. I think the only question from the chat I'm seeing is someone likes asking where the name Baldric is coming from for your home machine.
Asking the important questions. Well, of course, it's a Blackadder character, right?
Like, I kind of remember Blackadder. Was it Mr. Bean that was in it, right?
Yeah, he was.
Rowan Atkinson.
Yeah, he was the what was it? Well, his name was Blackadder, wasn't it? Of course. Yeah. So yes, that's where it comes from. It comes from Blackadder. I like to name my computers and systems after the laptop behind me is called Magrathea because we're building the new internet for the world at Tailscale. So a Planet Builder, Magrathea, right?
Nice.
My personal laptop's called Slarty Bart Fast. So I'm a nerd. What can I say?
I think the other question I had was, and also maybe going to the building blocks. You mentioned the Tailscale network. I'm assuming that's like a common network that I create that I will put my devices into, or my clients or in servers. Could I have the same device be part of multiple networks, or how would I think about that? If I,
all right,
I have a client that needs to talk to a bunch of different servers. Some of them, do they all need to be in the same network, or can I have the same device in multiple networks, so I can share networks across? How would that look like?
So this is the Tailscale admin console right here. I'm going to blow it up a little bit so it's a bit clearer for folks to see. And you can see here that I've got currently 4 nodes in my tailnet. I have my laptop, I have an LXC container in my basement, the Azure VM, and of course the EC2 instance down here. These 4 nodes are all in the same, what we call a tailnet, a logical grouping of Tailscale devices. Now, you are asking, can I share these nodes with other people, or like, how does that work? Like, can these nodes be part of multiple tailnets at the same time? No, not really. And that's simply a limitation of network routing, really. If you think about what's happening under the hood, if you wanted to connect the EC2 instance, for example, to Baldric, right, that's going to pull down a routing table from the Tailscale coordination server, because that's another role that this coordination server fulfills, is kind of keeping track of all the different subnet routes that we publish and the exit nodes and like all the different IP rules that have got to be created for all of this stuff to actually work. if you start have multiple tailnets, you've got to have a way of telling the TCP/IP stack which interface to start sending this traffic out over. Now, I can't speak to. I think this is a very secret feature, but it's a request we get quite a lot. I'll just leave it there. It's a request we get quite a lot. We hear you, and maybe something's coming. Maybe. No promises on timeline though. But the short version for now, at least, if you want to access a device from one tailnet in another, is something called node sharing. So, do you have a laptop in front of you, Tom?
I do.
All right, I'm gonna send you a. What's the easiest way to send you a link?
I think if you copy the link, you should see it in the chat on where we are right now. There's like a let's see.
Okay.
Yeah, there's a studio chat that you can share it in.
There we go. All right. If you don't have Tailscale installed, now is your time to shine.
Okay.
I want you to try and connect to this node in real time. This is even more sketchy of a live demo than the last one. But essentially, what's going to happen at the end of this is I'm going to let you access this node, which is behind my residential firewall. Again, I'm sorry to belabor the point, but no ports are open. And you're going to be able to route traffic to this node from your house. And we're not going to have done any special setup. You can see that in real time, look, shared out +1. You can see you've just accepted that invite.
Yeah,
now,
that was me. I went ahead and joined it.
Oh, okay.
Oh,
cool.
That's why. Can multiple people join it? Because I wonder if for me it's taking forever right now. So
like
I wonder
if anybody in the audience that has Tailscale running, possibly.
We haven't shared it to the audience. That could. I don't know how risky you want to be in
That's
terms
fine.
of.
I might unshare the subnet if we do that, though, because that for my entire LAN, you can potentially
limit the access.
Yeah, I love you all, but I don't necessarily want to give access to my LAN. So yeah, what we're doing here really is showing the power of, like, if for example, I wanted to share that database with the developer friend when I was a student, right? I could share, and this is all on the free tier. You don't need to pay us any money to get access to these features. It's only when you want to start exceeding the 3 users number of seatings that the pricing starts to come into effect. So if you've got 10 or 20 people all wanting to be members of the same tailnet and manage your identity and have 100+ nodes, that kind of thing, that's where pricing would start to come into play. But until then, it's a very generous free tier, particularly for people at home that just want to try it out and get started for free. It's absolutely no cost, no credit card or anything like that required either. So
okay. So for some reason the page not loading for me. Is this the same link that you would use for multiple people? If you're okay, I can share that link with.
I think I made it a share. Yeah, it's a reusable link.
And you can see where I connected right there. So
you can see that Alan's connected. Can you get in, by the way, Alan? Does the SSH
Oh, actually, work? You know what, Alex? It's go back in there. The reusable was not checked. Okay, copy. Okay, that one's a reusable one, so that one should work. So I think that other one might have been a one-time one.
Oh, I think so. Right, let me put that in the chat then.
And Alex, just confirming, are you okay with me sharing this with other folks in the audience?
Yeah, no, it's the same link, Alan. It's a reusable one.
Oh, okay. Okay,
let's see if anybody else has success with it. We're going to share it in the chat.
Yeah, so if you want to connect to that node, you would need to use the fully qualified domain name, which again I will put into the studio chat, which is hiding over here. There we go. So this speaks to another thing you get for free with Tailscale is fully qualified domain names. All right, so if you go to the DNS tab, you'll see that each tailnet gets a fully qualified domain name for free on ts.net. What this enables us to do is provide Let's Encrypt based certificates for free with TLS and fully qualified, through Let's Encrypt and TLS to provide basically a reverse proxy for free as part of the product. So the way you would connect to it is using the fully qualified domain name. Any luck?
Not for me. I don't know if I'm having issues with DNS.
Oh, it's always DNS.
Always DNS.
How about you, Alan? Can you connect all right?
Yep, I am connected. I have it into our demo telnet, Alex's basement, same IP address.
All right. Let's just can you prove to the ladies and gentlemen that you're connected? You need to send me a wall command or something. I don't know, something silly.
All right, let's do that. All right, so I just pinged it. I got a direct connection on ping there. I shouldn't be able to SSH into it, correct? Or can I?
I think so. You can try.
All right, let's find out. Oh, yeah. Oh, permission denied. I am permission denied.
I've done something funky with my ACLs over here. I'm sure of it.
You want to check if other folks were successful? Because I've shared the link with the audience. I wonder if anyone else tried to connect. Don't know what's going on with my DNS. I don't want to troubleshoot my network while I'm on the stream.
On the fly, break something.
Yeah.
Yeah, no. Right now, at least, it's just Alan. So,
and it might be if they don't have Tailscale, a Tailscale account, you're going to have to create one and create your tailnet. I already was connected with our existing tailnet, so I was able to add his shared node into my tailnet itself. But for users that might not even have Tailscale, kind of walk through. We have a little bit of a wizard that walks you through, setting up Tailscale and connecting. So maybe some users might be doing that.
Yeah. So Alan, you have your own tailnet, and I would have my own tailnet, but I would see Alex's node appear in that tailnet.
Correct.
With I'm assuming a new IP address, or you always use the same network for all of the components in that tailnet? Is it always 100 dot something?
So we use the CGNAT space. So every tailnet has access to 4.1 million IPs. So the whole 100.xyz schema CIDR range is available. So in my telnet, I see Alex's laptop as the same IP, 127.120.110.
Mm-hmm. Okay. So that's why it makes sense why you can't have multiple tailnets, because you already have access to the one and only tailnet of everything. You just on a per user basis decide which components and which devices are going to be in there, but ultimately it's the same network. So that makes sense.
Yeah.
So I got a question from the chat about performance, and I think I had the same thoughts actually. Right, with number of clients, but we also haven't talked about throughput. Right. So if there's what should we think about from a performance perspective here? Because I'm assuming there is, like with a site-to-site VPN, so folks probably are already familiar that with a site-to-site VPN to AWS components, you're getting around 1.2 gigabits second, right? That's a network-to-network connection, and that occasionally becomes a bottleneck for what you can send. So you have to add multiple VPNs. Like with the full mesh of a peer-to-peer VPN connection, I'm assuming that's going to be a much better story here. So I'm curious if looks like Alex
So we
is
have.
already.
Yeah, well, Alex is getting that. I could talk to on the scale up and performance. Dominic, great question. We have today, we have customers that run thousands of nodes within their network. In fact, one large client on a daily basis will scale up a few thousand nodes. They use it a lot for CI/CD and ephemeral networking. So they'll have maybe 5,000 spin up one day to do a lot of build stuff, and then it will tear down that night. Tailscales, because it's really a mesh and it's not really all hinging on one concentrator or one device, that it can scale very rapidly with as more devices on there. One of the reasons everybody has a 4.1 million IPs per. Originally, when Tailscale was built, it was actually the whole 100 range for everybody. Well, 2.5, 3 years into Tailscales, we were founded in 2019. So about last year when I first started, they were like, folks, we're about 2.5, 3 million IPs being used out of this 4 million range. And we're going to run out because we got all these devices for different customers, even though they couldn't see one another. Just the overall pool was shrinking because we were using one pool for everybody. So our engineering team put on their hats and went and basically said, let's just give everybody access to 4 the whole CIDR range. I think it's a /16, I believe it is, for everything. So to answer your question, yes, will scale very well. We have customers using it today in production with thousands upon thousands of clients. What we do see, Alex mentioned something like subnet routers. One thing we do see with customers scaling that is they'll have multiple subnet routers, and a lot of that performance, like if you're on AWS, you don't want to use something like a burstable CPU. You want to have a good size instance VM with some solid cores because it's very CPU intensive. And then we have the ability to have scaling as well. So you can kind of scale these devices as more traffic comes through. You can even scale that pipeline as well.
Got it. So the subnet routers, I think we probably know them more as just an EC2 instance that's an entry node into the network, right? So it was running at Tailscale's. You guys call them agents or clients?
Yep, clients.
Clients. So it's running a Tailscale client. You can connect to it and then use it as a jump-off point to connect to other things. So I see how, if everybody is connecting to that one node and that one node then needs to expand to multiple things, you now need to worry not about your Tailscale performance, but about the performance of that EC2 instance.
Yep. Yeah. All that encryption, decryption coming through, it's gonna melt it. I think in Alex's testing the other day, you were mentioning that your micro instance kind of fell over.
Yeah. So I ended up. So what we have here are they're T3 medium on the AWS side and the equivalent on the Azure side. So you can see the Amazon one has 4 gigs of RAM. The Azure one has 7. The RAM's not super important, but they're both. In fact, it looks like Amazon are running their data centers at absolute zero, minus 273 Celsius. That's quite a feat of engineering, chaps. Good job. So I'm running down here. On the left is the Amazon side. On the right is the Azure side. I'm running BTOP in both places. And what I want you to pay attention to is the CPU utilization right here. We're running on a 2.5 gigahertz core. So not the fastest core, not like a modern, like a 4+ gigahertz gaming chip or something like that. But, for the data center, sort of 2 gigs is about what you see typically out of a Xeon. So what I'm doing here is I'm running iPerf on both sides. So the Azure side is acting as the server. And remember, there's no firewalls configured. These I'm not using publicly accessible IP addresses. The security groups for both of these are set to allow SSH only. Like if I was to try and connect to Azure with a public IP, well, first of all, it's in a NAT. It's in a NAT group on the Azure side, so it wouldn't work anyway. But secondly, the firewall rules that I created on both sides would preclude us being able to use port 5201 anyway. So iPerf is running 100% over Tailscale. Now, first of all, I'm going to do this single-threaded. And watch what happens to the CPU. You can see sort of 18, 20% on this side, 15, 20% on the Azure side, right? That's for a single thread, and we're getting sort of 330 megabits of bandwidth. But if I pump that up to have 8 threads, we'll see, hopefully, this routes at somewhere approaching, there you go, gigabit a second. And remember, this is running in user space in the WireGuard Go code that we write. This isn't a kernel level module or anything like that. So it's incredibly performant considering it's not part of the kernel. The downside of that, of course, is it does use a little bit of CPU when it's really pushing. So look at the CPU usage here when we're doing the 8-thread test. It's pegging a single core basically at 100%, right? It's not a very well multi-threaded workload, and that's because of the UDP acceleration. So what you might see if you're trying to do this through pretty much any commodity hardware, like maybe a Unify firewall or some kind of an OpenSense box or something locally, is you might see some, particularly on the lower power things like the Unify gear, you'll run into headroom issues with UDP packet acceleration, just simply because it requires a lot of CPU, as you can see as part of our demonstration. I think if I do T0, it will just keep running forever. So I'll leave that running in the background, just sort of to be a visual aid, and hopefully the bandwidth charges don't hurt too much.
Get your free credits, right? Free
right,
and Azure credits, burning through them today.
So I just want to get people to sort of think back 20 minutes. Like this virtual machine here, this EC2 instance was completely vanilla. Tailscale wasn't even installed on it. And in the process of this live stream, we installed Tailscale, and now we're routing packets across multi-cloud infrastructure without having engaged the network team anywhere. You know, there was no clicking, there was no click ops, there was no messing about with Terraform templates, there was no CloudFormation involved. It was literally just connect these two nodes to Tailscale and they will find the path between them. And that really is the magic of Tailscale right there, is the fact that you can get on with doing the stuff that's actually important instead of fighting network topologies, and, you know, just enjoy the direct connections. Now, what I want to point out to you here, and I did this on purpose, Tailscale ping 100.109, that is the Amazon box pinging the Azure box. And it did that going through what we call a DERP server, was it direct something relay proxy? What's the word, Alan?
Designated encrypted relay for packets.
There you go.
Yeah.
I think our engineering team had a fun afternoon when they came up with that one. But anyway, they're called DERP servers. Essentially, you can just think of them as a relay server. And so if you are having performance issues, one of Alan's colleagues, a chap called Lee Briggs, did a webinar on the Tailscale YouTube channel fairly recently, talking about client connectivity basics and how when you're routing through these DERP servers, you might see performance loss. And occasionally we will see situations where people are behind particularly tricky NAT situations. A carrier grade NAT sometimes with Starlink can be a problem. For those that aren't familiar with Starlink, you don't get a public IP address on your WAN side. You get a Starlink LAN address, and then they have the WAN IP somewhere else. So you are like double natted within the network topology there. So punching through that one can be a bit tricky. Also, sometimes we encounter what we call hard NAT on AWS. And that's simply because of the NAT gateways that you guys have, and it's by design. It's a security feature. And so in that situation, you will need to allow a couple of UDP ports through your firewall just to make sure that the DERP servers can basically, and the coordination servers can basically find each other and actually talk to each other and exchange the few packets of information that they need to in order to sort of orchestrate that connection. But you can see that it's pretty quick at, in an optimal situation. It's pretty quick at finding that direct connection. It sometimes takes 3 or 4 pings to actually find the direct connection there, but in this case it just took 1. And then you can see I'm directly connected to Azure that way. So that's it.
So from a performance point of view, we're seeing kind of a close to a gig per second between 2 nodes. Now, if the same server needed to communicate, and let's forget about these being T3s, I think the burstable up to 5 gigs, but assuming I have a beefy enough instance. If I have multiple connections to multiple destinations, right? So I'm talking to multiple servers. Would my because typically what we've seen with IPsec performance is you're getting that 1 and a bit gigs because you're locked down to a single core, because that's effectively a single flow. I don't know if you're talking to different destinations, setting up tunnels to different destinations, are you able to make use of different cores and ultimately get that close to 1 gig on every single Tailscale or WireGuard tunnel to appear, or how would that look like?
Well, that might be a situation where the subnet router becomes useful for you. You can then offload the processing to a box that is better suited to the task of routing network packets than just general purpose compute like this. We quite often see the performance through a subnet router is, I don't say often, but we have seen it where it's higher than a direct connection. The subnet router is still making a direct connection underneath, but the overheads are kind of shifted around a little bit and different things are doing different steps. So I've just spun up iPerf in my basement, and just for fun, I want to see what happens. I think I have 5 gig fiber. I don't know if it's going to be able to make the connection or not. I would have thought it could, but maybe not. You know, so from my perspective, it's connecting through a relay server. So this is Amazon talking to the thing in my basement. There we go. All right, let's see if this works now. Is it going to work? Helps if I set the correct command line flag. There you go. All right, so this is Amazon talking through my residential unified gateway, which is going to be the limiting factor here to the performance. You can see that this is the LXC running in my basement, which is just running on a little Lenovo 1-liter PC with a 10 gig SFP NIC in it. If I do 8 threads on this one too, I wonder what happens.
You're going
But
to
yeah,
max out your link and we'll lose you in a second.
I doubt it with Unify. So there you go, 200 megs, 250 megs a second. I mean, considering residential networks aren't peered anywhere near as well as AWS data centers, I'm pretty happy with that, to be honest. Just for, if I wanted to run a Nextcloud instance or a photo backup server or something up in the cloud, or I'm not doing serious business here. I'm just, doing dad level infrastructure, I'll call it.
Okay, so we do have some additional questions from Dominic, and kind of the direction. I think I have some follow-ups too, from a audit or inspection. So I think we chatted on the podcast about inspection, because we see that a lot where customers are going, hey, I want to see what's going on with the traffic, but at the same time we talked about how much control you have. Maybe that's worth showing. How much control do I have as an owner of the service, of how do I decide what can talk to what? And then from a logging perspective, I think that's also a good question. Like, what can you see when things are getting logged?
Okay, so I'll pass this to Alan in just a moment, because I know he's got some thoughts on the logging side. But I'll just I'll just walk you through the Tailscale admin console portion of it. First of all, there's a dedicated logging tab up here. And as part of the premium plan, this is one of the things that isn't included in the free tier. We can enable something called network flow logging. On top of that, there is a bunch of other stuff where you can see here that a few people actually accepted my invite in the stream. And you can see that created the node share, deleted the node share. Like, so in terms of auditing what's going on, I could present this log to an auditor and they'd be extremely happy. You can go in and see like which invite created it and blah 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 blah. So Alan, do you want to talk a little bit about the network traffic logs?
So everything is encrypted, and one of the things about what's happening over your tailnet is there's no audit later inspecting the live traffic. So our network flow logging is, as what it describes, the logs and flow of networking devices. So if Alex's tailnet was tied into like Datadog or Splunk or Elastic, you could actually see source, destination, how many packets at what timestamp that they were sent across. And so when we look at companies from an observability, or they have a SIEM or some sort of platform to say what's happening in our network, you can pull this, you can build your charts. We provide their JSON kind of formatted logs. You can pull them down from the API, you can curl them. We have a couple of native integrations here. So if you have Splunk, Elastic, Cribble, which is like a catch-all, that you can actually ship those logs. A new one that's incoming is the ability to even save these to S3. So that's a requested feature that we're super excited about, because customers are like, hey, I want to keep them, but I don't have an observability platform, but I want to dump them to S3. So that is actually something that is being worked on with our team right now. So we're, from an SE side, we're pretty excited about that for all of our AWS customers that are asking about that. But those use cases, that log, right, as it mentions there, centralized logging, compliance and auditing, the network flow logs. I'm never going to see what Alex was doing with iPerf. Like, oh man, he exchanged a ton of packets at this timestamp. I don't know what he was doing, but I can see when it happened. So if you have correlation with let's say a service or an application, all of a sudden it went down or it crashed or just got unresponsive, and you had network flow logs, you can look and say, oh, Bob had logged in and exchanged a whole bunch of packets, and then 30 seconds later, the server just went unresponsive. And you could probably call Bob up and say, hey, what happened here? What were you doing? And some of that human aspect of it, just kind of checking in of what's happening along that line.
So in the flow logs, or sorry, you keep calling the flow logs or net logs, basically net flow logs, I'm assuming. Would you see the devices that are being involved in the exchange? So would I say it's Baldric communicating with the EC2 instance, and this is the amount of data, these are the ports that were used? Obviously, you wouldn't see the layers
correct.
Upper layers.
Yep, you'd see the source. So you'd see the Tailscale IP address as well as its node ID, because each device has a unique node ID, and then you can see its destination and as well.
Got it. And then do you ever get asked for kind of a being able to run a packet capture. I know we get those requests for some of our services. Hey, can I do a full-on
We
packet
do.
capture like a
I mean,
TCP dump?
for
But I guess,
troubleshooting, we have customers that will ask them sometimes to run Wireshark and send some PCAPs for some deep troubleshooting. Now, granted, a lot of it's going to be encrypted, but it gives you that ability to at least analyze. What Alex just showed here, we have the ability to, there's streams PCAPs as well as running what we call a Tailscale debug command, so these log files are stored, again, part of that coordination plane. They're up there. And our support team, engineering team, if we have an issue, hey, we got connectivity issues, what's going on? We can run these PCAPs or a debug command. And what that does, it tags within the log files because they're very verbose, being able to see, so our engineering teams can go back and look at saying, oh, we've got some weird DNS errors here or some routing misconfigurations. Again, we're not seeing what the traffic is, but that network health of what's happening within the tailnet itself.
Yeah, it's still encrypted, but you're seeing, the TCP exchanges and acknowledgements and seeing if there's any retransmits, things like that. So that's super useful.
Yeah, it's a super helpful troubleshooting piece, being able to analyze and say, hey, what is going on? Because when you're dealing with Tailscale that overlays all these various networks throughout the world, there's all kinds of weirdness, right? And most of the time it just runs smooth, and that's part of the magic of why Tailscale is it just works and people love it and why we love it. But some of these deeper packet inspections or being able to look at that, it can be helpful for troubleshooting.
Mm-hmm.
Yeah, there's all sorts of useful tooling buried under this debug command. I didn't even know about this one. Tailscale debug resolve. You can test what DNS stuff is coming back if you don't have dig installed or something like that on your box. There's a bunch of other stuff too, and we have, so the capture thing here is doing PCAPs, so it uses WireGuard under the hood to capture the packet, the PCAPs, and then there's a bunch of stuff. I'm going to see what this dirt map does. There's a bunch of stuff in here I didn't even know existed. This is fun. Dirt map. There you go, and it just prints it out. Do I have JQ on here? No. Okay. Well, it prints out a bunch of stuff. You can see that London, for example, LHR, is operating here, and it has a certain latency to where I am. If I did a Tailscale, I think it's net check. I can list out all the different relay servers and how well I am peered to each of those. This is from my house, by the way. So, New York is 15 milliseconds, and Nairobi is the worst one at 247. Sydney just gave up, and Bangalore and Joburg, they all just gave up. But the point is, the DERP network is very well geographically distributed. So there's almost always going to be a relay server close to you.
Yep. I'm seeing there's a comment from TechField. I think it's what you mentioned, Alex, earlier about, our NAT gateways making it a little bit more challenging with being able to punch those UDP holes and having to do that extra configuration to make sure that you can hit those DERP servers.
Yeah, we have specific K-base articles on what exact stuff you need to forward and where in terms of ports and things like that to get through those more tricky situations. Essentially, the coordination servers need to be able to reach each node somehow over. Where is the page gone? Over UDP. So if we jump into Tailscale, how NAT traversal works. If you haven't read this post, by the way, and you're curious about what we're talking about today, highly recommend giving this post a read. It really, you will learn something. I almost guarantee it. But essentially, what we're trying to do is rather than have this VPN hub server in the middle, we're trying to find a way to get through these firewalls. And so we kind of abuse a mechanism in NAT itself, which when this laptop makes an outbound connection, it then opens itself inbound on that port for a few moments to say, okay, when I get the response, it's okay, you can come through. And so essentially that's what Tailscale is doing to kind of punch through the NAT there. What happens when you have a particularly, I forget the name of it off the top of my head, but when you have a particularly tricky NAT situation that doesn't allow that inbound connection, even though it's allowing outbound stuff, That's what we call hard NAT typically. And so that's where you as the admin will just need to configure a couple of UDP ports to allow the discovery piece to happen between the coordination server, and then it can do the mapping to get through the various network topologies that way. I appreciate that that's a largely not a very common use case that we see from people, but it is an important one, and we do have a workaround for that, like I say, with just configuring a couple of pieces of firewall.
Yeah, that reminds me very much about the Stan and Tran turn servers used with voice, where you have similar challenges where you need to do these punching calls through different NATs.
And that's another reason that we recommend the subnet router approach for people in the VPCs, is because sometimes it's much easier to peer just that one instance and get that going through a security group correctly than it is to try and get an entire VPC's worth of resources that could well be ephemeral and auto scale and blah, 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 blah. If you just have everything routing through that subnet router, you probably save yourself quite a lot of headache. Now, I'm going to bring up a page from our KBase here, which is the AWS reference architecture that we make available. It's very high level, but you can see here that there's a bunch of stuff like we have a Kubernetes operator, so you can actually run Tailscale inside of your EKS clusters. Likewise, you could just have a straight up EC2 instance, or you could have an EC2 instance acting as a subnet router to connect to RDS, S3, or any other AWS services behind it. So that's really in a nutshell, I hope, answering the question around that. If it doesn't, let us know in the chat, please, and we'll dig into it a little more if we can.
And then the other part of the question was about inspection, which ultimately I think translates to access.
Mhm.
Do you want to share a little bit about how you control access? I know initially when we were doing the demo, you mentioned the tags weren't configured. Sounds like that got solved on the back end. So I'm curious, sounds like you can do tag-based access controls, which sounds pretty neat.
Who doesn't love a JSON file to configure their infrastructure, right? So for those people in the audience who are GitOps nerds, and I hope there's a couple at least, I want to just highlight first off the bat that you can actually control and manage this file using a Git repo. So you can make changes programmatically to this and have a proper PR process around the controls that are here. It's not just a free-for-all free text file, that anybody can go in and change. I mean, that's how it is out the box, right? Anybody that's got access to the tailnet and is a certain tier of user. So let's jump back to users for a second. You can see that my user here, Pangolin, is currently the owner of this tailnet. Now imagine that I had 20 or 30 users in this tailnet. There'll be a bunch of different roles available, from members to auditors to network admin, right? We're all fairly used to, role-based access at this point. But within the access controls piece, you can see I can start to group those users together. So I can create a group here called admin, called dev, and list the members of that group specifically here. What that then allows me to do is reference this entire group of people in rules later on. So if I want, for example, to be able to say that the group of developers can only SSH into nodes tagged as dev as the user deploy, then that's what this rule here would permit or deny, depending on what you configure, but just under this specific stanza right here. Now, there's a bunch of other stanzas in this file. You've got tag owners. So remember I was talking about the identity piece earlier. And if I go back to my machines page, I want to show you, just highlight the difference here. This node, basement LXC, is owned by a tailscale@gmail.com. That's me. I'm the person that authenticated this node to the network. So I typed in Tailscale up and I clicked the login button and I went through the process of manually adding this thing to my tailnet. This node, however, was created by Terraform and it was automatically added to my node using infrastructure as code tooling. There's no way for me to manually type as part of that process. Of course, this wouldn't be programmatic if that was the case. So when we do that, we add this, the owner becomes, it's kind of hard to explain, but the owner becomes a tag instead of a person, right? So when I share a node that is a tag, it's kind of weird that you're not sharing it as a person, you're sharing it as a tag owner. So if I look in my access controls, you can see I've defined a whole bunch of tags here that inherit a whole bunch of other rules based on the tags based on the group, sorry, that was set further up here. So the owners of the dev tag, for example, are admins and group dev. Does that make sense?
Yep.
Okay, good. I never know because sometimes I ramble. I also want to draw your attention to this here, because this actually tripped me up for quite a while when I was fairly new. This hosts block here. You might think to yourself, well, doesn't Tailscale already have a mapping of host names to IP addresses? Why do I need to define it manually here? And one of our engineers said, yeah, but Alex, what would happen if someone changed the name of their node in the tailnet and simply by virtue of the name got granted access to resources that they weren't supposed to have access to? And I was like, oh, good point. So by putting that in the file here and explicitly defining it, we can control people having access to those resources a lot more explicitly. What we can then do is we can use these essentially like an alias. So if you have a look for one of these host aliases further down in, where is it? Yes, in my tests here, for example, yes, you can write unit tests as part of this ATL file. As we all know, every good developer should start by writing the test first and then write the code second. That's at least the way I was always told to do it and never did. You can see here I'm referring to a node with a specific name, and then that references the alias further up in the file here, saying the test. I must always have a rule that makes sure that Baldric can SSH into fake NAS on port 22. And then there's a bunch of other stuff we could get into. Now I'm going to make a change here. I'm just going to add Amelie to the admin group just to show you what happens. I'm also going to make a mistake deliberately. You can see, first of all, the syntax highlighting is telling me something's wrong. So this is not just your standard text field, right? This is a smart text field. If I click save now, you can also see that it's got some validation. Okay, it's telling me that line 5, column 47, I've made a mistake. Line 5, okay, yeah, silly boy. Now, if I click save over here, you see it validates this time. Now, another thing I want to point you to, I think it's under logs. Is it logs? Yes. So you can see in the logs section here that Pangolin, yes, that's me, updated the policy file for the tailnet. Now, if I click down here, I get a nice git diff style display showing me exactly what changed and why. Now, if I came in here as a network admin and went, Alex, what you doing? I can click on revert to previous version and revert. And again, if I go back to my tailnet policy file now, you'll see that Amelie is no longer an admin, and the world is all happy and rainbows again. That's a quick overview of ACLs. Sorry, Alan.
No, the revert actually happened in our demo telnet because a bunch of SSEs are always changing ACLs. And I went in on Monday and I was like, whoa, they're all default. What happened? We had this huge, because we're not using GitOps. And going back into the log file, being able to find out when Friday at 2 p.m. and then revert back to that version. It was nice. It's a good, nice saver there for sure.
Oh yeah.
I always like a good diff file to be able to revert to. That's
right.
Makes life so much easier.
Now, another thing that we haven't touched on yet is something we offer called app connectors. These are essentially a little bit like a split tunnel for DNS. So let's say, for example, I always wanted to access my online banking through a node that's running in this house. Right? I'm abroad and my bank, for some reason, doesn't like it when I go to England. Okay, fair enough. I could do one of two things. I could go up here to my Tailscale client and I could select an exit node. Now, I don't have any available right now, but what an exit node does is it lets me route all of the traffic. So it does a complete rerouting of all the packets from this device out through the tailnet, apart from local addresses. I should just caveat that. Mm-hmm. Any address that isn't a local address goes out through the tailnet. We're all familiar with that with like privacy VPNs like Molvad and that kind of thing, where once you connect to the VPN, all of your traffic appears as if you're coming out of that other geographic location, right? What you can do with an app connector, though, is you can enable this on a per domain basis. So we have split DNS tunneling in the Android app on a per app basis. But here, for example, I could say, I want to route all of my GitHub traffic, this is just an example, to go out through nodes that are tagged as app connector, for example. And what it will do then is you can then configure the connectors which allow the traffic to route out through that. So anytime I go to github.com, it will route as if the traffic originated through that other node on my tailnet. Now, this can be particularly useful, like I say, for security conscious applications like banking, but there's a million other use cases as well. Like you don't necessarily want the front door to an admin console open to the public internet, but you could just as easily have that running on a node that allows incoming connections from a specific IP that is trusted, and then route all the traffic through that node that way and come out safely. So once you start being able to connect everything to everything, you can do some really pretty interesting stuff.
That is definitely interesting. What's the, out of curiosity, what's the kind of weirdest use cases that you guys seen your customers kind of deploy? Because you can kind of create really wild architectures, right? Spanning the whole world ultimately.
I think the weirdest for me is someone running it on a robot vacuum.
Robot vacuum, farm equipment running GPUs, so tractors that are applying weed spray, but using GPUs and Kubernetes clusters to spray these, so they're all over. Tailscale running on every one of those tractors or clusters to take snapshots, and they can real time stream performance. We see a lot of IoT use cases as well, edge industrial sensors and devices that are really lightweight, and they just want to pull observability data or metrics. And they'll use Tailscale as that bridge to pull things across.
Yeah.
As you know, I do a little bit of podcasting on the side too, and the probably strangest use case that we've come up with for the podcast is my co-host lives full-time in an RV, but he has a studio back in Seattle, and so he was several hundred miles away in Phoenix, and he was controlling his mixer using a Stream Deck on the desk in front of him over Tailscale as if he was in the same room as the mixer. I thought that was pretty cool.
But so he was also sending audio through that path as well?
Correct. Yes. So he was routing my audio into the studio in Seattle, his audio into the studio in Seattle, also recording a local backup in case his Starlink went wonky. But then he was actually controlling the mixer using a Stream Deck from his laptop.
Nice.
In the woods in Phoenix. Well, not many woods in Phoenix, but you know what I mean. Like in the
cactus, in the cacti in Phoenix.
Yeah.
Oh, that's funny.
Yes, it just changes the game. And before I worked here, it was one of those things that I just saw it appear one day in the Synology App Store, and I'm like, what's this Tailscale thing? I'll give it a go. At the time, I'd actually just fairly recently written the documentation for WireGuard for OpenSense. I was a really big WireGuard user before I moved here, and I set aside an entire weekend to switch to Tailscale once I figured out what it could do for me. And I was like, oh, I'm done in 10 minutes. Now what do I do the rest of my weekend? I know, I'll go play Factorio. It's fine. But
everybody played. I've never actually, just a sidebar, but I haven't played the game, but everybody, like every second person I'm meeting recently is playing it, and I'm worried I'm gonna
Pandora's box, Tailscale with Factorio. Here we go.
Yeah. Next live stream on Twitch won't be AWS speak, it'll just be Factorio. There you go.
Yeah, you won't even be on the AWS part. You can just be on the straight down Twitch streaming of
right.
video.
Yeah. So what else can we answer for you? Is there anything else in the chat that we need to cover off?
I think we've hit all the big points. Do we want to check if folks, I'm kind of curious if folks were able to connect to your node. I don't know if they
won't be able to SSH. I think I realized after the fact that you can't SSH to shared nodes. You'd need to be a member of my tailnet. But you should be able to at least ping it. And if I was running a web service, for example, on that node, this is how I actually share a lot of self-hosted applications with the rest of my family. For example, we have a family Nextcloud where we store all of the important legal stuff like passport scans and what have you. I obviously don't want that stuff on the internet, but sometimes, it's useful to be able to have a birth certificate at your fingertips, even on the other side of the world.
Yep.
So that's what we use that for. And I run a reverse proxy on those nodes. such that I can use the subnet routing on that node from anywhere, and my family can also connect in and connect to any of the self-hosted services in this house from wherever they are. And I know I keep talking about the home lab stuff, but you could just as easily extrapolate a lot of these use cases to a lot more business focused stuff too. You know, I talk a lot about because I'm in DevRel these days. I talk a lot to folks who are doing test dev environments, and they want separations of concern, so they have different tailnets for dev and different tailnets for test, and users actually just switch between them in their clients on their computers. Like, I'll just show you on the screen share how easy it is to switch between. I've got 3 tailnets on this laptop. I can just select any of those 3 at any time, and I can have a completely different network context. Like this Gmail one up here, for example, my personal tailnet, I could route packets into my mother-in-law's house in Norwich in England, as well as stuff in my basement and stuff in the cloud. And like, honestly, it's all just like a flat network to me these days. I don't even think about it.
Nice. I can see the value in having like separate tailnets, right? Complete separation of UTs and accessing different networks.
Yeah, you can do a lot with ACLs, but there really is nothing better than complete, like break glass. Like, you've got to log into a separate account to get to production. You can do a lot with ACLs, but like I say, there's sometimes a use case where 2 separate accounts is the way to go.
Mm-hmm. I see this. We can probably touch on one more questions here on patching and upgrade process from Dominic. How does that look like?
Typically, we release every 4 to 6 weeks, give or take. Where is it? Tailscale releases change log, something like that. You can look at all of the change log stuff here. All of the clients are fully open source, so you can go to GitHub and validate the source code. The central control plane is closed source, but we make the change logs available here for you, and they are freely available to read whenever you like. And you can look here. So October 16th was 1.76. October 10th, sorry, was 1.76, and 1.74 was October what was that? September the 12th. So it looks like roughly every 4 to 6 weeks is about right. And in here, there's a bunch of different change logs pertaining to all the different platforms, Linux, Windows, Mac OS, etc. You can do on certain platforms. I know on Linux, for example, Tailscale has an auto update mechanism built in if that's your bag. Not all platforms support that. Obviously, on things like Mac OS, iOS, tvOS, those kinds of things, it's all you get it all through the App Store anyway, so you're at the behest of the Apple approval process for those. But again, those all pretty much go out on the same day, give or take, and you get them through the App Store that way. I hope that answers the question.
Yeah, I think that's perfect. I don't think we have any other questions. There's some excitement about the story you shared, and I think folks want to watch the video on demand. For people that are still on, if you want to give us feedback or if you want to provide topics for future sessions, I just shared a link to a survey that you can fill out for us. But we don't have any other questions. So Alex, Alan, thanks a lot for joining. Enjoyed having you guys here, and everybody else, we'll see you next week for the routing loop session. Thanks, everybody.
Thanks for having us. It's been a pleasure.
It's awesome. Appreciate it.
So long.